Everybody, this is single phase semi controlled rectifier fed DC series motor video. In this single phase semi converter, that means bridge fed DC series motor circuit shown in this slide, it consists of two thyristors in upper arm and two diodes in the lower arm of the bridge converter, which make symmetrical connection. During positive half cycle of the source, the thyristor T1 and diode D2 get forward biased. Thyristor T1 is triggered, that means fired, and it starts conduction, and diode D2 is also conduct from alpha to pi. Now, inductor stores the energy for this duration. Thyristor T1 and diode D2 are turned off at the moment of supply voltage crosses 0. For this period, freewheeling diode FD or FWD get forward biased, which starts conduct to form pi to pi plus alpha and ensure the continuous load current through the load and voltage across the load is 0. Then during negative half cycle of the source, the thyristor T2 and diode D1 get forward biased. Thyristor T2 is triggered, that means fired, and it starts conduction, and diode D1 is also conduct from pi plus alpha to 2 pi. Now the conductor stores the energy for this duration is repeats similar to positive half cycle. The freewheeling diode provides power factor improvement and continuous load current of speed torque characteristics. It has some average DC output voltage V0. That DC output voltage V0 equal to Vm by pi 1 plus cos alpha. Next, we have to see single phase fully controlled rectifier for DC series motor. In this circuit, 4 thyristors are used and connected in bridge form to act as converter and supply DC voltage to the load. Compared to the half wave circuit, this circuit has a much improved form factor of the output voltage or RMS and average voltage. In this circuit, inversion and regenerative braking is possible. For continuous conduction, the armature voltage or average DC output voltage is given by V0 equal to 2 Vm by pi cos alpha. It has some limitations. That limitations are 0 less than or equal to infinity less than or equal to pi. When Vm is peak or maximum voltage, it has some modes of operation. There are two modes of operation. One is continuous mode conduction, another one is discontinuous mode conduction. Continuous conduction, during positive half cycle of the supply, the thyristor T1 and T3 are forward biased and fired simultaneously at Wt equal to alpha. Thyristor T1 and T3 are conduct from alpha to pi plus alpha, and motor is connected to supply. At Wt equal to pi, output voltage Va is negative, that means reverse, but load current in the same direction. If motor current flows supply minus T1 or T1 motor T2 supply, the during next negative half cycle, the thyristor T2 and T4 are forward biased and fired simultaneously at Wt equal to pi plus alpha. If the thyristor T1 and T3 are turned off due to reverse voltage across them. Natural or line commutation basis this reverse voltage across them. Motor current flows supply T2, motor T4 supply, again supply. Next, speed control of DC shunt motor using semi-controlled rectifier. That semi-controlled rectifier also having some fully charged rectifier fed separately excited DC shunt motor. It has some quadrant type, so that relation is only valid for continuous current mode. The average behavior of the rectifier over a period of the output voltage. This single phase fully controlled rectifier fed DC separately excited shunt motor having some continuous current supply. This has some disadvantages of proposals, that is low DC output voltage, low DC output power and lower efficiency, higher ripple voltage and ripple current, higher ripple factor, low transformer utilization factor. Then the input supply current waveform has a DC component which can result in DC saturation of the transformer core. Thank you.